Okay, so we've had some fun with some very interesting kind of problems, talking about some basic exponential and logarithmic equations. Now, we might want to talk about one or two different types that we had not discussed before. And this is a really interesting one. What would we do if we had an expression like this one? Well, we've got e to the positive x plus e to the negative x over 2 is equal to 15. And it's not as though we can just take a logarithm on both sides and be rid of the problem, right? Because we have no property that tells us how can we divide up a logarithm of a sum, right? There's nothing else we can do with that. So, right, there is no property for that. So there's nothing I can really do to simply divide these up just by dropping a logarithm on both sides. So I have to take advantage of a little bit of algebra first. So let's rewrite this over here. What I'm going to do is I don't like fractions in my equations, and so of course I'm going to multiply both sides by my least common denominator of 2. When I do that, I get this equation. E to the x plus e to the negative x is equal to 2 times 15, that's 30. And that's our equivalent statement. Oh, so you're looking at that and saying, well, all right, so you got rid of the 2, but we still have another problem. What about this e to the negative x? Well, we do have a property for negative exponents, and that is that it becomes a fraction, and we can treat it as e to the x plus 1 over e to the x equals 30. And the reason why I might recognize why I do that is to get rid of that denominator, which is e to the x. So what do? I'm going to multiply both sides by the common denominator, which is e to the x. So I'm going to multiply e to the x times e to the x, that's supposed to be an e, plus 1 over e to the x, and that will give me 30 times e to the x. So if I distribute, what happens? I get e to the x times e to the x. That's e to the 2 times x, right? E to the x times e to the x. That's squaring. So that's e to the 2x. Then I'm going to take e to the x times 1 over e to the x. That's plus 1. And that will equal e 30 times e to the x. You know, I'm looking at this first term right here, and I think a lot of people get confused about that one. So I'm going to rewrite it in a way that's a little bit more useful to me. What did we really do, right? When we said e to the x times e to the x, well, we were squaring e to the x. And so now you think to yourself, oh, wait a minute, this looks like it's a squared quadratic form equation. And in fact, that would be right, because if we set this whole equation equal to 0, by subtracting 30x from both sides, look at what happens. I've got e to the x quantity squared minus 30 times e to the x plus 1 is equal to 0, right? Now you might recognize, oh, this is sort of a quadratic form equation where I have something that looks like u squared minus 30u plus 1 is equal to 0. So I'd want to go through and see if there's some way for me to solve this equation. Clearly, it's not directly factorable because we'd have to be able to find two factors that when you multiply them together give you u squared as the first term and 1 as the constant term. And then give you negative 30 as the middle term. Yeah, it's not directly factorable. But, right, again, recognizing that u is replacing the quantity e to the x, what could we do? Well, one thing we could do is complete the square right here, since it's a nice even number in the middle term, and we already got u squared up front. Let's just take advantage. So I have u squared minus 30u is equal to negative 1. And I would complete the square by taking half of 30 and adding it to both sides. So I'm going to have u squared minus 30u plus the square of 15 is equal to negative 1 plus the square of 15. Well, what is 15 squared? Well, don't forget 15 squared. 15 times 15 would be the same thing, really, as the number 225. Now, I did go through a trick on how you can actually square two-digit numbers that end in 5 very quickly, but in this case, we'll just take it as read. It's 225. So what have we got? On the left-hand side, we have u minus, from the sign, 15 quantity squared is equal to negative 1 plus 225. So our algebra tells us that this is really u minus 15 squared is equal to 224. So we take the square root on both sides. U minus 15 would be equal to positive or negative the square root of 224. Now, of course, we need to ask, is there anything that we can do with 224? So u minus 15 is equal to positive or negative 4 times the square root of 14 when we reduce that down, right? Don't forget that what's happening right here is we take that 224 and break it up to look for the perfect square factors. And so u would have to be equal to 15 plus or minus 4 times the square root of 14. In fact, 15 is greater than 4 times the square root of 14, right? Don't forget, this 225 was 15 squared, so 224 has a square root that will be less than 15. And we're looking to see what happens for e to the x. So what is that going to be? That's going to be saying e to the x is equal to two numbers, 15 plus 4 times the square root of 14, or e to the x would be equal to 15 minus 4 times the square root of 14. Both of these are positive numbers, and so it is possible for us to get two solutions. X is equal to the natural log of the quantity 15 plus 4 times the square root of 14, and x could equal the natural logarithm of 15 minus that, right? So the natural logarithm of 15 minus 4 times the square root of 14. All right, so that's the solution we were looking for in this problem. Good luck. We'll see if we can try some of these in class as well.